Welcome to a slow, beginner-friendly lesson on recapping Python functions, made for absolute beginners. Take your time. Functions are worth understanding slowly. Today we recap functions, the whole of phase A.3 in one calm lesson. What a function is, when to write one, how to define it, how the body runs, how parameters bring data in, how return sends data out, and how calling lets you reuse the same work. We do not start libraries yet. Just functions, solid again. If any piece feels weak, you can rewatch a single A.3 lesson later. Here is the chain you built. First, what a function is, and when writing one is worth it. Then the skeleton, def, a name, parentheses, a colon, and an indented body. Then inputs with parameters, outputs with return. Then the call that actually runs the body, and reuse, calling the same function again with new values. We will walk that chain once more. Keep this map in mind as we go through examples. A function is named work you can run again. That single idea is the heart of everything we review today. Hold that idea, a name for work you can run again. Ask a practical question: will you reuse this work, or does it deserve a clear name? If yes, write a function. If you are still exploring and the steps are unclear, plain lines are fine for a while. You can always extract a function later. The goal is judgment, not forcing def on every 3 lines of a throwaway experiment. Good judgment beats copying function recipes you do not understand. Imagine you typed hello Ada, then hello Grace. Same pattern twice. That is a signal. You define greet with a name parameter, then call greet Ada. One body, many greetings later. You did not invent a function on the first keystroke, you noticed reuse, then named the work. That is healthy beginner judgment. Notice that greet Ada and greet Grace share the same body. Programs move step by step. First you store a function, then you call it, then the body runs. Storage first, then execution. That order will save you from confusion. Defining and calling are not the same moment. When you write def greet, Python stores the function. The body does not run yet. Nothing is printed. Later, when you write greet with parentheses, that is the call, the trigger. Now the body runs. If you forget the parentheses, you only refer to the function object, you do not run it. Remember, define stores, call runs. Say it out loud. Define stores, call runs. Type def greet with print hello inside. Finish the definition. Still quiet, no hello yet. That silence is important. The work is stored, not executed. Now type greet parentheses. Hello appears. 2 steps, store, then run. If something surprises you, check whether you actually called, or only defined. The quiet after def is normal. The call is what makes something happen. Try tiny functions live. Type a def, call it, read the result. Mistakes are cheap in the shell. Small experiments teach faster than long theory alone. The body is the indented block under def. Both print A and print B belong to show because they are indented. On each call they run top to bottom, A, then B. When you dedent back to the left, you leave the function. Indentation is structure in Python. Wrong indent is not a style nit, it changes what is inside the function. If print is not indented under def, it is not part of the function. When you call a name, Python first checks that the name exists. If not, you get name error, usually you forgot to define, or you defined it later. If the name exists, Python enters the body and runs the indented lines from top to bottom. If the body hits return, that value goes back to the caller. If there is no return, the result is none. Then control returns to you. Trace one call in your head, name exists, body runs, value comes back, parameters are named inputs. When you call add with 2 and 3, those values fill A and B inside the function. The body computes. Return 5 sends 5 back to the caller. If you want to use that answer later, assign it, total equals add of 2 and 3. Print only shows something, return hands a value the program can keep using. Parameters are the slots, arguments are the values you put in those slots. Define add with 2 parameters, A and B, and return A plus B. Call add 2 3. You get 5. Then total equals add 10 1, total becomes 11. One function, 2 different pairs of inputs, 2 useful results. That is why parameters and return exist, flexibility without rewriting the body. Same function, different inputs, different results, that is flexibility. Show doubles and prints. You see 10, but you cannot easily feed that number into the next calculation as a return value. Give doubles and returns. X becomes 10. Same math, different job. When the program needs the number, return. When you only want to display, print is fine. Choose on purpose. Ask, do I need this number later? If yes, Return it. Double of 7 returns 14. The shell remembers that as the last result. Underscore plus 1 becomes 15. You are chaining from a returned value without retyping the whole call. That only works because double returns something, not merely printed it. The last result is only useful because something was returned. Write the work once. Call it many times with different values. That is the real payoff. One clear name, many uses. That is everyday programming. Here is the payoff. You define square once. Then you call it with 2, with 3, with 4. Each call is independent. The body stays the same, only the argument changes. If you find a bug in the math, you fix it in one place, every call benefits. Copy-paste would force you to fix every copy. Functions win for consistency. Reuse is not fancy. It is simply not repeating yourself. Define square once. Call with 2, 4. With 3, 9. With 4, 16. Feel how cheap the second and third calls are. You already paid for the definition. Reuse is not advanced technique, it is everyday practice once you trust return values. 3 results from one definition. That is the habit to keep. Triple of 2 is 6. Double of that 6 is 12. The inner call runs first, its return value becomes the argument of the outer call. Composition needs return. If triple only printed 6, double would have nothing useful to receive. Small functions connect through return values. Small functions connect when each one returns a clean value. If you type hello without parentheses, Python shows you the function object. The body does not run. No hi. Add parentheses, hello parentheses. Now hi prints. When nothing seems to happen, check for missing parentheses before you rewrite the whole function. Parentheses mean, run this now. Soon you will import modules full of functions other people already wrote. Same idea, named work you call. Import will feel familiar once calling your own functions is natural. Quick self-check. Can you define a function with no parameters and call it? Pass a parameter and return a value? Store the result in a variable? Call the same function 3 times with different inputs? If one step feels shaky, go back to that single A.3 lesson. You do not need to rewatch the whole chain. Honesty with yourself here is more useful than speed. A function names a block of reusable work. Def stores that work, a call runs it. Parameters bring data in, return sends data out. Reuse means one definition, many calls. Next you will meet libraries, collections of functions other people already wrote, waiting for you to import and call with the same habits you just reviewed. Carry these 4 lines into every later lesson. After this recap, Phase A.4 continues with modules and libraries, why code lives in many files, how import brings a module in, and how you use one standard library module carefully. Then a gentle introduction to objects and methods. Same slow pace. Same one idea at a time rule. Your function skills are the foundation for all of that. Libraries are just more functions, organized into modules. If you want a 5-minute practice, define Celsius to F that returns the conversion. Call it with 0, you should see about 32. Call it with 100, about 212. One definition, 2 calls, return values you can trust. When that feels familiar, you are ready for libraries. If you are tired, skip the practice, the ideas still count. 2 calls are enough to prove the definition works. Thanks for reviewing functions with me. See you in what libraries and modules are. You have the function foundation. Libraries come next.